Hey guys, today we are going to discuss all the ICSE question of 2016, 2015, 2014 and 2013 that are asked from the topic force and moment of force. Absolutely, this is 100% important for your ICSE. Do watch videos before solving. I have uploaded many videos of force on my channel. You should first watch them. Okay, let us begin from ICSE 2016. So the first question reads, a stone of mass m is rotated in a circular path with a uniform speed. Okay, note the question, uniform speed, by tying a strong string with the help of a hand. Is the stone moving with uniform or variable speed? So we have one stone which is tied to a string. See, we have a stone which is tied to a string, and here is my hand, and I am rotating this stone in a circle. Okay, so I have to apply force and rotate it like this. So the first question is the stone moving with uniform or variable speed? So see, the answer to the first question lies in the question itself. It says with a uniform speed, and the question is the stone moving with uniform or variable speed? Definitely it is moving with the uniform speed. So simple. Next question, is the stone moving with uniform acceleration? Oh, so that's a good question. Whenever a body moves in a circular motion, it experiences a change in direction. Yes, the body changes its direction. Suppose here the body is going like this, over here the body goes like this, over here it goes like this, over here it goes like this. So the speed is uniform. That means the value of the speed is same everywhere, but the direction is changing, due to which there is a change in velocity. You see, velocity is a vector quantity. It depends upon direction. So the direction changes and hence velocity changes. Velocity is what? Velocity is speed along with direction. So you see, the speed is same everywhere, but the direction is changing, which brings us to change in velocity. Now whenever there is a change in velocity, we get acceleration. So what kind of acceleration acts over here? The name is centripetal acceleration. And what is the direction of centripetal acceleration? Always towards the center. Always towards the center. So the acceleration over here is like this, towards the center. If the stone is over here, the acceleration will be like this. If the stone is over here, the acceleration would be like this. So the acceleration always acts towards center. Now the question is the stone moving with uniform acceleration? Uniform means same. Is the acceleration same everywhere? No, it is different. You see, the direction of acceleration is changing. Over here, the acceleration is in this direction. Over here, in this direction. Over here, in this direction. Over here, in this direction. So, acceleration is not uniform. You may say it is always directed towards the center, but wait, over here, the center is on this side, and over here, the center is on this side. So over here, the acceleration is directed towards a left, and over here towards right. So the acceleration is not uniform because what is changing? The direction of acceleration. It is changing. Okay. What kind of force acts on the hand and states its direction? Okay. So I am using my hand and I am pulling this stone towards the center. That is why it is rotating like this. Yes. Now, what kind of force exists in the string? In the string, the force which exists is the tension. Whenever we hold a string like this, okay, the tension over here is away from the point like this. And if I ask, what is the tension over here? Away from this point over here. So the question is, what kind of force acts on the hand? So in my hand, there will be a tension force. And what is direction? Away from my hand, like this, away from the hand. So these were the questions which were asked in 2016. Let's move to 2015. A nut is opened by a wrench of length 20 centimeter. If the least force required is 2 Newton, find the moment of force needed to loosen the nut. Okay, so here is a nut, and to open a nut, what we need? We need a wrench. Okay, you must have used this somewhere, a wrench over here. Now you rotate the wrench like this, okay, you push it like this and it holds the nut and opens the nut, okay. So the least force required is 2 Newton. Now where do you apply the force? Yes, over here, over here, over here. No, of course at the end. So you apply the force over here and the force is 2 Newton and the length is 20 centimeter. So this is the length of the wrench. Okay, and the length is 20 centimeter. This device is called a wrench. Okay, 20 centimeter. Now what they have asked, find the moment of force. So the formula for moment of force is force multiplied by perpendicular distance. So the force is 2 Newton and distance is 20 centimeter. So I convert it into meter. Okay, divide by 100. So we get 2 to the 4 by 10 Newton meter. Okay, so that is 0.4 Newton meter. This much moment of force is required. Now the next question is, what is the SI unit of moment of force? That's an easy one. The formula for moment of force is force into perpendicular distance. Force has a unit Newton and distance has a unit meter. So here the unit will be Newton meter. Okay, the next question is, on what factors does the position of center of gravity of a body depends? Okay, so suppose this is some body. Okay, where is the center of gravity? At its center, over here. Suppose this is some body, this is a ring, or this can be a disc. Where is the center of gravity? At its center. So they have asked, what factors does the position of center of gravity body depends? So there are two main factors. First is the distribution of mass. Distribution of mass. In what way the mass is distributed? Suppose in this figure over here the mass is more. Okay, this side have a great mass and this side have less mass, like this. Okay, some lesser mass over here. So where will be the center of gravity? Where will be the total center of the mass? It will definitely be towards this side. Yes, because this side has more mass. So it depends upon distribution of mass. And what is the next factor on which it depends? It depends upon the mass. Okay, if there is no mass, there will be no center of gravity. One more thing, it also depends upon the gravity. Okay, if there is no gravity, there won't be no center of gravity. So basically it depends upon mass, distribution of mass and gravity. So what's the next question? Name the factors which are affecting the turning effect of a body. So you can see over here, the turning effect basically depends upon moment of force. If you ever want to turn a body, turn means rotate a body, you need moment of force. So moment of force has formula force into perpendicular distance. So it depends upon what? It depends upon force. And next is the perpendicular distance. What is this perpendicular distance? The distance over here, I'm explaining you. Suppose if we want to rotate a body, okay, over here it is fixed, this rod is pivoted over here, fixed from this side, and we want to rotate this rod. So we apply a force over here. If I apply a force over here, it will rotate very easily because the distance is large. But if I apply the force over here, I will require a greater force to rotate it because the distance is small. You see, moment of force has a formula force into perpendicular distance. So if you increase the distance, the force will be less. If you decrease the distance, the force will be more. If you can see, when we open a door, we apply force at the farthest end. Okay, over here the door is fixed. I'm taking an example of door. This is fixed. This end of the door is fixed, and over here is the handle. So we apply force over here so as the distance is large. If the distance is large, the force required to open the door will be less. So it depends upon force and it depends upon the perpendicular distance. And what is this perpendicular distance? Distance of pivoted point where the body is fixed from point of action of force. Okay, this is the pivoted point and this is the point of action of force. But wait a minute, it somehow also depends upon the orientation of force. Wait, if I want to rotate this body, this is fixed like this over here, what will happen if I apply the force like this? Will this body rotate? No, because you are pushing it. It won't rotate. So it also depends upon direction of force. So what are the factors? Direction of force, the force itself, and what? The perpendicular distance between pivoted point and the point of action of force. Okay. So the next question we have is define equilibrium. Now what is equilibrium? What really is equilibrium? Equilibrium is that state of body in which the net force on body is zero. What will happen with the net force zero? You see, the formula for force is mass into acceleration. So if force is zero, acceleration will also be zero. You see, this quantity is zero, so this quantity must be zero, because mass cannot be zero for any body. Okay, any body which is existing will have mass, so acceleration will be zero. So net force on the body should be zero, which donates the net acceleration should be zero. One more thing, when acceleration is zero, the body cannot have linear motion. What motion? It cannot have any linear motion. No, it cannot have. Maybe it can, but only with constant speed. Confused? What do you mean by acceleration is zero? See, acceleration is change in velocity divided by time. So if acceleration is zero, change in velocity and on time is zero. That means change in velocity will be equal to zero. What do you mean by the change in velocity is zero? There is no change in velocity. The velocity is same. So we can say it moves with constant speed or constant velocity. Okay. So if the net acceleration is zero, the body will move with constant velocity, and maybe the velocity is zero everywhere. 0, 0, 0, 0. That means the body is at rest. Over here, the velocity is again constant. So if a body is in equilibrium, what will happen? The net acceleration should be zero, which means the velocity is zero, or the velocity is same everywhere. If velocity is 4, it will remain 4 throughout, or if it is 0, it will remain 0 throughout. So all this what only related to linear motion. You know, we have another kind of motion. What kind of motion? We have rotational motion. Yes, we have rotational motion. And to stop rotational motion, we need moment of force equal to 0. If there is no moment of force, there can be no rotation. And if there is no force, then obviously there will be no acceleration. So there are two conditions. First, the net force acting on the body is 0. And the second, the net moment of force should be 0. Net moment of force 0 will give you rotational equilibrium, and net force 0 will give you what? Translational equilibrium. What is translational equilibrium? Translational means linear equilibrium. So what happens in equilibrium? Does the body stay at rest? No, it's not necessary. At equilibrium, the body can move, but only with constant velocity. So either the body is at rest or it moves with constant velocity, and the net moment of force is 0 and the net force is also 0. This is equilibrium. Say here is a mass, and apply 2 Newton force on this side and 2 Newton force on this side, 2 Newton on this side and 2 Newton on this side. So what is the net force? You will say the net force is 0, and hence this body must be in equilibrium. Moreover, the net moment of force should also be 0. I should give you an example. Suppose we have a rod over here and it is pivoted at this point, fulcrum. I apply 2 Newton force from here and 2 Newton from here, and suppose this distance and this distance are equal, they are the same. So what will be the moment of force from this side? 2 Newton into D, like this, and over here 2 Newton into D. That means the net moment of force is 0. So that's what all about equilibrium is. Okay. Let us go to ICSE 2014. 2014 had some more questions, but they are out of syllabus, so I am not discussing them. Determine the magnitude of resultant moment of forces about midpoint. So one force is over here. Now I'll keep the fulcrum like this, and the force is applied like this. So it will rotate the rod like this, and this force is applied in the upward direction. If I apply the force like this, okay, wait, I have to fix it. If I apply the force like this, again this will rotate in this direction. If I apply the force like this, it will rotate in this direction. So this is a direction anti-clockwise, and this is the direction anti-clockwise. Yes, so both are having the same direction. So the net moment of force or the resultant moment of force can be found out by adding their moment of force. What is the moment of force of this force? So the formula for moment of force is force into perpendicular distance. Yes, so the force is 5 Newton multiplied by 50 divided by 100. I converted it into meters. So 0 0 cancel, 5 5s are 25 divided by 10, that is 2.5 Newton meter, and the direction is anti-clockwise. This is the moment of force due to this force. Now due to this force, the moment of force will be again force into perpendicular distance, and that is again what? 5 Newton into 50 divided by 100, that is 2.5 what? Newton meter anti-clockwise. So what is the resultant moment of force? Since both the moment of force are in the same direction, we will add them, and the resultant will be 2.5 plus 2.5 will be 5 Newton meter, and how? Anti-clockwise. Is that clear? 5 into 50 upon 100 plus 5 into 50 upon 100. Some people may think it's 0, but it's not 0. See, both the forces are trying to rotate it in anti-clockwise direction. Yes, so the moment of force will be added. Now I move to ICSE 2013, and 2013 has this question. The position of center of gravity remains same. Yes, remains same, unchanged, even when the body is deformed. True or false? It is false. Yay, so simple. Why false? Suppose we have a disc over here. It is a disc. Where is the center of gravity? The center of gravity is at the center. What will happen if I deform this? Suppose I cut this part out. The body will be like this. Oh, 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 like this. Now where will be the center of gravity? Definitely the center of gravity will be somewhere here. Earlier the center of gravity was here. So the center of gravity has shifted. So definitely if you deform a body, center of gravity changes. Why? Suppose this is a rod. Where is the center of gravity? Over here. What will happen if I cut the rod from here? If I cut the rod from over there, the rod left will be this. Yes, this part is cut out. So the earlier center of gravity was over here, but now this much rod is left. Where will be the new center of gravity? Over here. So the center of gravity has definitely changed on deforming a body. The next question is, where is the center of gravity of a uniform ring situated? So the most easy one, this is a ring and it is uniform, so the mass is same everywhere. Where is the center of gravity? Definitely at its geometrical center. So that's all. You can ask your doubts in the comment section. That's it for today. Moment of force, all ICSE question. Enjoy.